Good afternoon, sir.
Good afternoon, beta.
Good
Good
afternoon.
afternoon, everyone. The recording of the meeting is on now. So let's continue with our discussion. So last lecture, beta, we had started off with
सर हमारा
the
लास्ट क्लास बहुत लेट खत्म हुआ है अराउंड 14:10 को तो सर 5-10
okay.
मिनट्स मिल जाएगा
Okay. What time you want me to start, beta? 1500?
1500.
45 ओके
Okay, no problem. Take your time. We'll start at 1500. No, not an issue.
ओके ओके थैंक यू
Okay.
सर और एक चार्ट वर्क का क्वेश्चन डाला हुआ है ग्रुप में, आप देख लेंगे सर एक बार, थोड़ा उसमें प्रॉब्लम आ रहा था।
Okay, all right. Let me see. Hello, beta. Good afternoon. All in. Shall we start?
Yes, sir.
Okay. All right. Okay. बेटा पहले आज का टॉपिक कर लेते हैं, then I'll pick up the doubts.
Okay, sir.
Yes, sir.
Okay. So, beta, last session we had started off with understanding of the celestial sphere. So I had covered up the equinoctial system with you, and I covered up the horizon system with you. Did I show you the PZX triangle also?
No, sir.
No, sir.
You do, sir.
The last thing which we did was the horizon system, true altitude, right?
Right, sir.
Okay, all right. So let's continue further. We will see the PZX triangle today. We will see how the PZX triangle is shown in the rational horizon diagram. And if you have some energy left, then we can continue on star identification. That's the plan of topics lined up. So let's start. Let me open up the presentation. So beta, this was the celestial sphere, the concept of celestial sphere and the equinoctial system. We discussed what is the celestial sphere, what are the celestial poles, what is the equinoctial, and what are celestial meridians. Then in the next diagram, we discussed about the horizon system. We found out that it is based on the observer's position. We obtained the zenith and the nadir. Then we obtained the rational horizon represented by NESW. We found out how these directions are marked on the rational horizon: north, east, south, and west. Then we saw what is a vertical circle. You see, from the zenith going up to the nadir, passing from the celestial body, that's a vertical circle. The red dotted line highlighted with maroon and green colors. And on this vertical circle, we saw the true altitude of the body, H2x, highlighted in maroon, and we saw the true zenith distance of the body, highlighted in green, that is Z2x. So I think this was the last I did, correct, beta?
Yes, sir.
Okay,
Yes,
all
sir.
right. So what we are going to do now is we have understood this horizon system. Look at this diagram carefully. Look at this diagram carefully. So from this diagram, we will try to understand what a PZX triangle is. So once understood, then it's a very, very important concept in celestial navigation, used in solving many of the questions. So we now proceed ahead. Have a good look at this diagram and let me know if you have any doubts anywhere.
सर ये एक बार जरा इसका डायरेक्शन एक बार फिर से बता देंगे बस ये नॉर्थ साउथ ईस्ट वेस्ट
Okay, बहुत simple है बेटा. Let's say you are at the position O, the topmost position on the Earth's surface in this diagram, and you are on a ship which is steering north 000, right? When you look out of the bridge window, you will be able to see the pole star, which is at the north celestial pole, right ahead of you at some particular altitude. Up to here, okay beta, correct?
यस सर
Okay. Now, if you draw a line vertically down from the pole, that line is going to touch your horizon at some point.
Yes, sir.
Now, wherever it touches, that is the north point. In this case, it will be right ahead of you. So this point is the north point exactly below the north celestial pole or the Polaris or the pole star. So north identified. Okay, up to here, beta?
Yes, sir.
Okay. Now once you identified north, then rest of the directions, they automatically falls in place. Exactly opposite to it, that means at your right astern would be the south point of the horizon. Exactly 90 degrees to the right of north, that means on your starboard beam you will have the east point, and exactly 90 degrees to the left of north, that means on your port beam you will have the west point. So these are the four northeast, southwest points representing the directions.
सर अगर ये जैसे जेनिथ अगर हमारा ये पोजीशन एन एंड एनसीपी के बीच में होता तो फिर क्या चेंज हो जाता?
ओके, यू मीन टू से कि हमारी पोजीशन जो है ये एन और एनसीपी के द जेनिथ इज इन बिटवीन एन एंड एनसीपी, राइट?
राइट सर.
ओके बेटा, ये चेंज नहीं होता. देन बेसिकली यू विल मेक द डायग्राम लुकिंग फ्रॉम द अदर साइड. ओके, सी, let us say right now you are on the Greenwich meridian. Okay, this zenith is representing the Greenwich meridian. If you want to take the zenith on the other side, you have to be on 180-degree meridian, right?
Right.
Right. In that case, we will be looking on the other side of this diagram. Means हम जो 180 डिग्री वाला मेरिडियन है उसे राइट साइड में ले आएंगे यहाँ पे, और जो ग्रीनविच मेरिडियन है इट विल गो ऑन टू द लेफ्ट साइड ऑफ द डायग्राम. और इन अदर वर्ड्स you can say we will be looking at the sphere from the east side. Now we are looking at it from the western side. In that case, we will look at it from the east side.
Okay.
Okay, beta?
Yes, sir.
Okay. In any case, the NCP has to be in the north direction. Whether you are at Greenwich meridian or at 180-degree meridian, in whichever direction the north celestial pole is or the Polaris is, vertically below that you will have the north point. Okay, so or beta, any more doubt coming to the mind? So shall we proceed ahead, beta, to the PZX triangle?
Yes, sir.
Yes, sir.
Okay, all right. Now, having understood both these systems of reference, that is the equinoctial system, which is based on equinoctial and the celestial poles, and the horizon system, which is based on the rational horizon and the zenith and nadir or the vertical circles. We can now move on to understand the concept of PZX triangle. So we will use the two systems which we have just now discussed to understand what is this PZX triangle. So PZX triangle concept is what we use in celestial navigation to solve most of the problems. In fact, I would say the entire celestial navigation is based on the PZX triangle only. As I told you in the beginning, that the concept of celestial sphere was assumed so that we are able to use spherical trigonometry to fix up the position of the observer or position of the ship using the spherical trigonometry formulas. These formulas are applied to the PZX triangle only. So let's go ahead and try to understand this. The diagram which you see on the right side includes only the things which we have discussed till now. We have discussed the equinoctial system. You see the equinoctial here. And you have both the poles. You can see the south celestial pole here. This is the north celestial pole. The semi-great circles joining them are the celestial meridians. You can see the celestial meridian represented here. Then you can see the rational horizon. Coming to the horizon system now. This is the rational horizon. You can see the nadir, as well as this topmost point on the diagram is the zenith. Semi-great circles between the zenith and the nadir, they are known as vertical circles. So you see this particular vertical circle here. And this is the celestial body, the red colored star which you see is what we are referring to right now. So if you consider this arc of the vertical circle contained between the horizon at point H up to the center of the celestial body, we just now saw that this is the true altitude of the body. So all these things we have discussed already. There's nothing extra here. And now we will try to see or find out the concept of PZX triangle, which is hidden in this particular diagram only. Now we know that this is the equinoctial, and the axis of the earth extended toward the celestial sphere. They meet at both the celestial poles. So this point here is the north celestial pole. Let's mark it as P. I have written NC also in short, just to show it that this is the north celestial pole. This point is represented by P. We have seen this is the rational horizon. This is the position of the observer, and a line drawn from the center of Earth passing from the observer's position, meeting up to the celestial sphere. It meets at what we call as the zenith of the observer. So this point is the zenith, and let us mark it as Z. We have the zenith point plotted on the diagram now. The celestial body's position is represented by X. So let's mark a X here. So we have the P point representing the north celestial pole. We have the Z point representing the zenith of the observer. And we have the X point representing the celestial body. And covered by these 3 points, that is P the pole, Z the zenith, and X the celestial body. This particular area which is covered by these 3 points is the PZX triangle which we are interested in. So you can see this PZX triangle on the celestial sphere, which we use to solve most of our celestial navigation based problems. Now let us try to go a little deep into the different parts of the PZX triangle. Now let's concentrate our attention to the Earth in the center. You see this circle here represents the equator. And this particular position, which is exactly on top of the Earth in our diagram, represents the observer's position. Now, if you measure this arc between the observer's position and the equator, where I'm highlighting using my laser pointer, so this arc of the meridian between the equator and the position of the observer is the latitude of the observer. Angle at the center of the earth or the arc of the meridian contained between the equator and the particular position is the latitude. Now, equator is projected onto celestial sphere as equinoctial. You see this Q point is represented here. The Q point represents the position of the equator on the celestial sphere, and the observer's position is projected onto the celestial sphere at the zenith. So at this Z point is where the observer's position is projected. So this arc which you see from the Q point to the zenith of the observer represents the latitude of the observer. Now, since Earth and celestial sphere are both concentric circles, whether you measure this arc on the surface of Earth or you measure it on the celestial sphere, the arc is going to remain the same. So ZQ or QZ is the latitude of the observer. Now we also know that from the equinoctial to the celestial pole, that is NCP, so pole to the equinoctial P to Q is 90 degrees. Every point on the equinoctial is 90 degrees away from the celestial pole. So P to Q is 90 degrees. Z to Q is the latitude of the observer, and this tells us that P to Z, this side of the PZX triangle, that is P to Z, will be 90 minus latitude of the observer. So let us highlight this side in yellow. You see the highlighted side PZ of the PZX triangle, and this is equal to 90 minus latitude, also known as colat. So PZ side of the triangle is equal to 90 minus latitude equal to colat of the observer. Let's also mark out the latitude of the observer. So you see equinoctial to the zenith, this arc represents the latitude of the observer. So we have labeled here as latitude on the diagram. So you can see the latitude ZQ and the colat P to Z, and both totaling up to 90 degrees. Pole to the equinoctial P to Q point is equal to 90 degrees. Now let's move to the other parts of this triangle. Now we move on to the PX side of this particular triangle, Papa X-ray. So this PX side, Papa to X-ray, is known as polar distance. You see X represents the celestial body and P represents the north celestial pole. So this arc basically tells us how far away from the pole the celestial body is. So this is known as the polar distance. Now, this particular dotted line which you see going from the north celestial pole, passing from the star and going up to the south celestial pole, this dotted line is the celestial meridian of the star. You see, we discussed the celestial meridian in the equinoctial system. So this is the celestial meridian of the star. Pole to X to the south celestial pole, and this celestial meridian cuts the equinoctial at this particular point. Now from this point, if you measure the arc of the celestial meridian up to the body X, this particular stretch of the celestial meridian. What is this? This is the arc of the celestial meridian contained between the equinoctial and the center of the celestial body. This is the definition of declination. I told you declination basically tells us how much north or south of the equinoctial a particular body is. So if you look at this arc, it represents the declination of the celestial body. It tells us how much north of the equinoctial our celestial body is. And we also know that pole to equinoctial. So from the equinoctial, if you go along the arc of the celestial meridian up to the pole is 90 degrees. Every point on the equinoctial is 90 degrees away from the pole. So pole to equinoctial is 90 degrees. Equinoctial to the celestial body, this arc of the celestial meridian is the declination that tells us that the px side, which we call as the polar distance, will be equal to 90 minus declination. So I have highlighted this px side with the maroon highlighter now, and this side is the polar distance of the body, telling us what is the distance of the body from the nearest pole, and this will be equal to 90 minus declination. So this is the px side of our PZX triangle. So two sides of the triangle are understood. Now let's move on to the third side. Now, if you move on to the third side of the PZX triangle, the third side passing from Z, going up to the X and going up to the nadir is the vertical circle passing from the body. This is the vertical circle which is passing from the celestial body. And we just now saw that the arc of the vertical circle contained between the rational horizon and the center of the body, that is h to x, is the true altitude. You see it is still marked in this diagram. This is the true altitude of the body. And we also know that any point on the rational horizon is 90 degrees away from the zenith. So z to h is 90 degrees. H to x is equal to the true altitude of the body. This tells us that z to x will be 90 minus true altitude. And this particular side is known as the true zenith distance of the body. In short, TZD of the body. So I have highlighted this side in green color. Let's label it as the true zenith distance, TZD, and it is equal to 90 minus true altitude. So 90 minus true altitude, the side is the TZD, the true zenith distance, and it is represented as the ZX side of the PZX triangle. So you can see the PZX triangle here represented. P to Z is 90 minus latitude or co-latitude. Z to X is the true zenith distance or 90 minus true altitude. And P to X is the polar distance of the body, in this case 90 minus declination. So these are the three sides of the PZX triangle. Beta, have a good look at the diagram and let me know if you have any doubt in any of the parts. All clear, beta?
Yes,
sir.
Okay, very good. Excellent, beta. You have understood a very critical concept of the celestial navigation, the PZX triangle. अगर ये समझ में आ गया है तो 50% सेल nav समझ में आ गई है.
सर पोलर डिस्टेंस अगर वो अपना जो बॉडी है वो इस तरफ हो तो प्लस हो जाएगा.
You mean to say the body with a southerly declination?
हाँ जी.
Right, beta, right. If the body has a southerly declination, it will be south of the equinoctial. And if you are considering the North Pole only, then in that case, the polar distance will become 90 plus declination.
Okay sir.
Okay. Okay.
Okay.
और बेटा और कोई doubt? Okay, great. So shall we move on to the rational horizon diagram now?
Okay, sir.
Okay, good. Now, having understood the concept of PZX triangle, we have first understood the equinoctial system, then the horizon system, and we are now able to see the PZX triangle on the celestial sphere. So let's now try to convert this PZX triangle to the rational horizon plane. Now this diagram which you see on the screen right now is exactly the same diagram picked up from the last slide. All the things which are mentioned here we have already discussed. You see this PZX triangle here. It is the same PZX triangle. PZ side is the colat 90 minus latitude. ZX side is the true zenith distance, which is 90 minus true altitude. The side HX represent the altitude of the body. And the third side PX is the polar distance, which is equal to 90 minus declination. Beta, let me just stop the recording and restart it again. It's 3:30, so we will have 2 sessions. Just give me a minute.